Okay, I'll be showing you number 13 and how to graph its first derivative and the second derivative from the given function. So first we're going to define what the first derivative is, which is essentially the slopes of the tangent lines of the function. So we're going to be focusing, so that being said, we're going to be focusing on its slopes in order to aid us in drawing its derivative. So we're going to look at the leftmost part first, okay? So we can see that it goes from a small number to a bigger number. So that means that the slope is increasing. And to the middlemost part of the function, we have, to the left of the y-axis, we have a line that is increasing. It goes from a big negative number to a smaller negative number. And it also passes this point right here where it becomes where the sign changes, which would we call that the point of inflection here. It goes from positive to negative. And also at this point, that tangent line is a horizontal tangent line, which means that the slope is equal to 0. So that we'll be keeping note of that while we draw the first derivative, but that's until later. Okay, so now we got to look at this function here, or not function, excuse me, this curve, and we can see that it goes from a positive or a huge number to a smaller number as time progresses. So it's a negative slope. And we're going to be paying attention to these signs, as this will greatly help us in in drawing the next graph here, the next set of points and curves. So, as I said, the signs are very important. So we know that the slope to the left of the function, or leftmost part of the function, is positive. So that means that it will be above the x-axis because all its values are, or its y values are positive. Okay, now we can see in the middlemost part, it's going to be positive to negative. So it's going to come from the above the x-axis and then transitions to below the x-axis. And we also have a point right here, which represents the horizontal tangent line that we found in the first function. So as I said, we're going to go from the above the x-axis, cross the point, and then go transition into the bottom or below the x-axis there. Okay, and then now we have our rightmost part, which we can see it's negative, so that means that would be below the x-axis. So it'd be like this. Yeah. Okay, and we're going to use the same method that we used from the given function to the first derivative, and we're going to apply that to the first derivative to the second derivative. So we're going to look at the slopes, and we're going to make this a little faster because I already explained the process. So we can see from looking at it, it's increasing, positive slope, decreasing, negative slope, decreasing even though it passes through. It's not a point of inflection anymore. So it's a negative slope, and it's increasing here, positive slope. Okay, we're going to keep these signs in mind while we draw the second derivative. So, second derivative goes as follows. Positive slope on the leftmost part means it's above the x-axis. We're going to draw this nice line. We're going to approach the asymptotes, not exactly touch it. Okay, and then we have two negatives. That means that both sides of the y-axis are going to have the negative curves, like so. Perfect. Okay. And now we're going to have the topmost or the rightmost function be positive. So it'll be above the x-axis. And there we go. And that's how you graph the functions.